We're going to get started in 2 minutes. We're going to start on birthday time. So you can just stare at me, stare at my computer. Can you guys hear me in the back? How am I? Too loud? Too soft? Good? Good? All right, great. Is the screen also clear from the back? I have a couple options for lights here. I can either like make it really dark so we'll all fall asleep, or we can keep it around this level. Is the screen visible? You guys are in the back okay? All right, great. All right, let's get started. Hello, everyone, and welcome to the first day of Data 8. Woo! So, I want to say welcome. If you are not aware, this is Data 8, also known as ComSci C8, also known as Stat C8, also known as Info C8, just because it's about to be confusing. But this class is a fairly new class. It was developed in spring 2015 by a bunch of faculty and students. And basically what I'm here for is to repeat what they said, but since they're not here, you have to deal with me. I'm sorry. So I'm going to be your lecturer for this summer. So you'll see me Monday through Friday, 1 hour or 2 hours a day. And you'll see my staff, the TAs and the tutor, and my tutor and my lab assistants, probably more than me. You'll see them like throughout the week at different points in time. If you want to get to know the staff, you can click on there and look at their beautiful faces. But my name is Sam. My office hours are Mondays 1 to 2 p.m. and Tuesdays 1 to 3 p.m. in 258 Corey. I don't have any office hours this week. Mine start next week. But if you would like to have an appointment with me, feel free to email me at any time at samla95@berkeley.edu. I want to start off with some logistical announcements. So enrolled in the class with about 15 students on the wait list. I want to let you guys know that we plan on taking everyone in the wait list into the class. Yay. We're waiting to hear back from the front office, but I'm going to let you guys know as soon as I can about that. But right now we're planning on letting everyone in, and we'll probably either grow the labs a little bit to fit everyone in, or we'll split into new labs. We'll let you guys know. As I said before, there will be no office hours today or tomorrow. Office hours will begin as scheduled Thursday, Friday of this week, and then starting from next week onward, we're going to follow our regular office hours schedule, which I'm going to like go into later on. So don't worry about that. Just know that if you see our scheduled office hours times, like there's no office hours today or tomorrow. We were originally not going to do office hours for this whole week, but then we realized that you guys have a homework due Friday, so we decided to have office hours Thursday and Friday. So you can thank my staff for noticing that. We also have a class piazza. So I believe most of you guys, I sent you guys an email to enroll in class Piazza, but if you guys are not, I'm going to post a link on our website in a little bit. So the Piazza is where we do most of like when we're not in class, we like to ask questions and get help for problems that we're working on, and Piazza is the way that we do that. So we use that for class discussions. Some classes have a meme thread. Some classes have threads where they complement their lecture. You can do that. That's totally fine. So up to you. You can use it for whatever you want, hopefully class related. And that's all the announcements I have. So data science. Yeah, that's why you're here. So what is it? Data science is drawing useful conclusions from data using computation. And the reason why data science came into being is because we had, so maybe like about 30 or 40 years ago, we had kind of two camps of people who studied different things, right? We had like the CS people who studied like all CS stuff, programming, computers, that kind of stuff. And we had the stats people who studied the math, like the numbers and how to draw conclusions from numbers. And for a long time, those two groups like lived happily separate from each other. And what happened in the last 10 years or so is that all of a sudden people started realizing that there's a lot of data that we now have in the world. For example, if you go on Amazon.com, every time you scroll or click a button, or even like, maybe they track your eye movements by now or something, but every time you do anything on Amazon.com, they'll like record that down, and somewhere, like someone will eventually look through it and say, oh, wow, like that person hovered over this button. Maybe I should recommend that, that product to him or her somewhere down the line. And basically what happened is there's a lot of data, and the tools that traditional statisticians had to work with were not enough, because we had so much data that we couldn't fit it on one computer. And what that meant was all of a sudden we needed people who could do both the computational side of it, working with large amounts of data, and the stats side of it, drawing conclusions from that data. And because there was not a lot of people that could do both, they made a new word for it, which is what we do when we have things we don't know. So we call it data science. Data science involves, broadly speaking, three main like steps in the workflow. So the first step is exploration, which is just simply identifying patterns in information. For example, if you are an avid Safeway customer like myself, you'll notice that the price of chicken fluctuates throughout the week. I like to go shopping at Safeway on Sundays when there's often sales on chicken. Pro tip, by the way. Oftentimes on Sundays, chicken is only $1 a pound. Amazing. Throughout the rest of the week, the price of chicken kind of fluctuates. I don't really know. I can't really judge like when chicken exactly is on sale or not, but I want to buy the cheapest chicken I can. What I could do is I can use a visualization. I can say, oh, like when I visit Safeway on these particular days, and I plot, like how much chicken was on Mondays versus Tuesdays versus Wednesdays versus Sundays, I can see the patterns that there are in the data, which is just the price of chicken. Inference involves quantifying whether those patterns are reliable. So if I visit Safeway 3 weeks in a row on Sunday only, and I see the price of chicken is $1 a pound, and I go on Wednesday and I see the price of chicken jumps up to $2 a pound, how do I know whether that's true all the time? How do I know that's actually a thing Safeway does all the time? Maybe I just got lucky. Inference is deciding whether or not the pattern that I observe is a pattern that Safeway is actually like putting into place. Although it's a little counterintuitive, we use randomization to do that. And it's not exactly clear, it shouldn't be exactly clear to you why that's true, but as we go further along the course, we'll see why randomization allows us to draw conclusions about reliability. Finally, the third step is prediction. So now that I know that I've been to Safeway a bunch, now I know on Sundays I want to go to Safeway in the morning so I can catch all the chicken for $1 a pound and just buy like 10 pounds of it for $10 and feed myself for like a month. Okay, so prediction is using the data that we've seen before, drawing a conclusion, and then making informed guesses and next things to do based on what we observe. That uses a cool buzzword called machine learning, and we'll be going into that. We'll be spending the last part of the class talking about that, and I hope that you guys will enjoy learning about that as well. So data science does not exist in a vacuum. So although in this class we focus on the fundamentals of data science, so we focus on learning the computation, we focus on learning the stats, data science is actually motivated by applications. So there's no reason to do all of this if it wasn't useful for something. And because of that, we have what we call connector classes for Data 8. Connector classes are basically run by faculty from different departments. We have a wide assortment of faculty from all over campus. We have connector classes on public health, on law, on ecology, like global warming, sea levels. We have classes on ethics. And each of those are taught by a faculty member from somewhere around campus who is really interested in kind of teaching you how you can use data science in their field of study, in studying law, in studying English, in studying whatever, and to use that to draw more interesting conclusions that people couldn't have done before without the use of data science. So this all sounds really great, but unfortunately there are no connectors in this summer because I think faculty are busy doing other things. But taking Data 8 this summer will allow you to take connector classes in the fall and beyond. So if you're interested in taking a connector class, I really suggest you look at data8.org/connector. And if you go to data.berkeley.edu, you can see the list of classes that we have available, like the list of classes we have upcoming in the fall and in the spring. And you can hopefully you can plan your schedule accordingly and take a couple of connectors, because to me, Data 8 is not Data 8 without something that's personal to you. And connector classes are one way of making it personal to you, making it personal to what you like and what you study. I think it's a good time for questions. Are there any questions about what I've said so far? Yes. Oh, could you say your name for us and your question?
Sure. My name is Jared. I have a question about waitlist. You said that you guys are going to work as soon as possible.
That's right.
Do you know if you'll get people off the waitlist by Friday? Because that's the last day to drop other classes and still get a refund.
Yeah, that's a great question. So Jared asked whether it's possible for me to let you guys know about the waitlist by Friday because of the ad drop deadline. And I'll do my best. I basically just send the email to them and hope that they respond. But since today's a work day, they should respond pretty quickly. I'll try to let you guys know definitely before Friday. Yes. Name and question?
My name's David.
David.
Slightly unrelated, but will the lecture slides be posted anywhere?
Will lecture slides be posted anywhere? Yes. As well as a recording of the lecture, which is highly convenient. So I'm recording the lecture right now, and lecture slides will be posted. They'll be posted on our website, data8.org/Su17.
And will they usually be posted before or after lectures?
My hope is to post them before, and we'll see what actually happens. But I'm aiming to post them maybe an hour before lecture. So that's kind of what I'm aiming to do. Yeah, thanks. Yeah.
Where can we find the homework assignments?
Where can you find the homework assignments? We'll be going over that today. We'll be going over that today during lab, probably. Yeah. Your name?
Alejandro.
Alejandro. Nice to meet you. Any other questions? Yes.
You had to tell us about the Sunday chicken sale on Monday.
Sorry?
You had to tell us about the Sunday chicken sale on Monday.
Well, yeah, what can I do? I couldn't. Well, did you guys want to have class yesterday? That's what I thought. So you guys can go to Safeway, wait a week, and get some chicken. All right, let's move on. So now we're going to talk about some boring stuff. Basically, as I mentioned before, I'm recording a lecture. I'm going to be posting the screencast online, but it's better to attend because you're more engaged, you're more focused, you're hearing me talk and looking at my arms swing around. So hopefully it'll entertain you guys some more. Twice a week lab is required and is part of your final grade. During lab, we have lab assignments that you will complete during your lab and turn in. Twice a week homework assignments. So we're going to release homeworks twice a week. And during the class, we have 3 projects planned. We're going to be giving you guys about a week or so to finish each project, and we won't have homeworks during the times the projects are released. So you'll either have homework to work on or a project to work on. Office hours, these are our scheduled office hours times. They're going to be Monday, Wednesday, 3 to 5, and Tuesday, Thursday, 1 to 3 at 258 Corey. On my slide, it says they start next week, but we actually changed it. We actually have office hours starting Wednesday and Thursday of this week. So Wednesday, 3 to 5, Thursday, 1 to 3. You can come through if you have questions about the class or about the homework. We do have one midterm in this class. It'll be held Friday, July 14th in class. So Fridays we have lecture for 2 hours. So instead of having a lecture that day, we're going to take a test. Yay. Our final exam is going to be held at the end of class, the last week of classes on Thursday, 2 to 5 p.m. There is no participation grade in this class. So if you've been following along with Data 8 the previous offerings of Data 8, you'll notice that sometimes there's a participation portion of your grade. During the summer, there is no participation portion, like there's no points allocated for participation. However, participation allows you to drop 2 homeworks and 3 labs. The way to earn participation is to attend lecture in weeks 2 through 8. So this week doesn't count because everyone comes to that lecture, these lectures. Once weeks 2 through 8 start, if you attend, I believe our policy is if you attend 4 hours out of 6 hours of lecture per week, we count your attendance for that week. Another note about labs, I'm gonna take questions after this. Another note about labs is if you cannot attend your scheduled lab, and for example, if you can't make it to a lab that week or you have an interview or something, that's totally cool. The way labs work is if you attend your lab, you get credit whether or not you finish a lab assignment. So if your lab is from 1 to 3 and you're working on it, and you get like maybe about halfway through or something, like from 1 to 3 p.m., we just give you credit. On the other hand, if you don't attend lab, you'll have to finish the entire lab assignment to get credit for the lab. Any questions? Yes. Your name and your question? Becca.
My question is, so you say participation lets you drop 2 homeworks, 3 labs, and that it's 2 through 8. How do you know that we're here? Like, do we sign in or something? Or?
Yeah. So how do I know that you're actually here and not just lying to me? We'll have a form that we send out. Of course, it's possible to spoof the form, but we'll try to use data science to figure out some way of making it statistically not very smart.
So it'll be online.
That's right. It'll be online, and I'll give you guys the form during class probably.
Okay. Great. Thank you.
Any other questions? All right. What's next? Okay, so that's kind of the logistical stuff. In terms of kind of the philosophy of this class, well, our number 1 priority is learning. Of course, that's why you're here. So learning, so in this class, the way we structure this class and the way we kind of created the material for this class is a little bit different, might be a little bit different from the classes you've taken before. And the reason for that is because data science is not really about finding the right answers, and oftentimes there isn't really like one clear-cut answer. In this class, we'll try to manipulate and structure the assignment so that there is a clear answer for you guys. But when you go into the real world and actually do data analysis or data science, there's oftentimes not really one clear-cut yes or no answer. And because of that, what we try to teach and what I hope you guys can understand by taking this class is that the questions that you ask are often more important than the answers and the conclusions you draw themselves. If you ask the wrong question, it doesn't matter how good your analysis is, you get a wrong answer. So in this class, to me, my hope is that you guys will not only learn the knowledge and the skills of analysis, of programming, all of that, but you guys will also learn to ask the right questions. Right questions about your data, right questions about your conclusions, right questions about your inner state of being or mind. Okay. This class we try to foster a positive and collaborative community. Data science is never done in a vacuum, and oftentimes, when one person goes off by herself or himself and does data analysis and comes back and says, "I had this great result," oftentimes what happens is because that person has been so far removed from everyone else for such a long time, they come back and the result is not valid, or times have changed and something else has come up. Data science is meant to be done in collaboration with other people. The reason why this class is pretty interesting to me is because we get a really wide mix of people who take Data 8. Last semester, we had about 50 or 60 unique majors. So 50 or 60 different majors in the class. And so during lab or during lecture or during office hours, you talk with people who are from all kinds of places, who study all kinds of things. And that to me is part of what makes Data 8 really fun. So we'll try to foster that community, but it'll be on you guys to share your knowledge, to share your perspective, to be a good student. As an addendum to that, the core staff and I are here to help you guys out. We're not here, our plan is not to beat you guys down to the ground and to make you claw your way back up to a grade that you want. Our hope is that we'll challenge you intellectually, we'll challenge you to think outside of the box and step outside your comfort zone, but we want to be here to help you guys out and to answer questions that you have. If you find a data set particularly interesting, like tell one of us, and we can give you some pointers on how to investigate that some more. We're here to help you learn and help you follow your dreams. If you want to know more about the specific policies that we have in this class, I suggest you check out data8.org/Su17/policies. It's also linked on the main course website. So you don't have to write down this URL if you just go down. If you just go to the Su17 website, it'll all be there on the top down bar. About collaboration. So again, asking questions is not only permitted, but highly encouraged in this class. We'll have many opportunities for you guys to ask questions. I try to provide some of those opportunities during lecture, and you guys have plenty of opportunities during your lab and during your office hours as well. Because of that, we allow you guys to discuss all questions with each other, except for exams, of course. Your lab assignments will be submitted individually, but they'll be graded on completeness and not correctness. So homework is also submitted individually, so you work on it alone and your answers are yours alone, but you can feel free to discuss your answers or discuss your process and what steps you take to get to your answer with your peers and with your friends. Projects are done in pairs. So projects typically we encourage you guys to find someone else in the class and particularly someone else in your lab, because we have some lab slots dedicated for working on the project. So I recommend that you guys find a partner in your lab to work on the project. But projects are also collaborative within your pair. There are some limits to collaboration, of course. So obviously, don't share solutions with each other. Because if you don't really understand something and you try to keep going in this class, eventually, it's like if you build a tower and you forget the important stones, eventually your tower will fall down. So that's why I recommend that you really try to convince yourself that you understand the material and work through it on your own. Because of that, we allow collaboration. We encourage it. Because the focus is on your learning and your personal gain from this class. Because of that, I suggest that you don't share solutions with each other, because doing so will result in you failing the class. So let's not do that. Any questions? Yes, name and question.
Oh yeah, I'm Emily. And
Emily.
If you miss a lab, you said you have to complete the lab. And then in that case, is the lab graded not just on completeness, but on accuracy as well?
Yeah, great question. So Emily asked, if we don't attend lab and have to finish assignment on our own, is it graded on completeness or correctness? If you do not attend lab, it will be graded on correctness. So we have auto-graded, we have tests that we have in the lab. You have to pass all the tests in order to submit the lab and get credit for it if you do not attend lab. Any other questions? All right, well, I want to now that we've gone through some boring stuff, I want to show you guys something kind of fun. And I want to introduce you guys, or show you guys, I want to give you guys a taste of what you will be doing today during lab, or tomorrow during lab, and for the rest of this class. We're going to be doing some data science. Oh, okay, my screen is big. I'm going to make that big. Let me try to see if I can hide that. So this environment that you see here is called Jupyter. Jupyter is a browser-based environment. So you visit a URL in your browser, and in that URL, we give you cells that you can write code in. Code is basically a command to your computer. Tell your computer, hey, I want you to compute something for me, like 2 + 3 or 5 + 7. And with that computation, we can do some analysis on data. Now, it's really unfortunate that every single notebook, or most notebooks, have to start with this massive kind of strange-looking text. It's not important for you guys to know how that works. In fact, today, it's not important for you guys to understand how any of the code that I'm writing works. By the end of this week and next week, hopefully you guys will have learned enough code to go back to this lecture and understand how this code works. So today, I'm just going to scare you with this, but in the future, you guys will understand how this all works. So I'm going to run this code. And what we're going to look at today is the text of a novel called Little Women. Have you guys heard of Little Women? How many of you guys have read Little Women? How many of you guys have seen the movie Little Women? Oh, wow, we have one very dedicated, loyal woman reader, Little Woman reader. So the text of Little Woman is available online because it was written quite a while ago, so the copyright has expired. So if I take this URL and open any tab in my browser and paste that in, I can actually see the entire text of Little Woman right here. Blah, 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 blah. Here are the contents. And right here, we start reading the novel Little Woman. Christmas won't be Christmas without any presents, grumbled Joe, lying on the rug. It's so dreadful to be poor, sighed Meg, looking down at her old dress. So we have the entire text here, and just from reading this text alone, we can kind of draw a conclusion from this text, which is a form of data. The conclusion that we can draw is that the characters in this novel are probably spoiled and like Christmas. But except for Beth, who says, "We've got father and mother and each other," said Beth contentedly from her corner. So we have Joe, Meg, Amy, and Beth. Joe, Meg, and Amy are currently not being so pleasant, and Beth is encouraging the rest of them. We've got father and mother and each other. If you want to draw more conclusions about this textbook, without having to read a textbook right now, because that would take longer than I had time for in this lecture, we can ask the computer to read the text for us. So what I'm going to do here is tell the computer to take all the text of Little Women and read it into the computer so we can do analysis. It takes the computer a little bit less time to read it than it takes for us to read it. So when I run this cell, it's going to run, and it's done. Okay? And what I can do now is start looking through. I can build a table to represent the text of this book. So I'm going to show you that I have indeed read in the text into my environment. As an aside, the language that we're going to be programming in this class is called Python. It's not super important for you to know like the details of this right now, but just know that the language is called Python. If someone asks you what you're learning in Data 8, you can say, "I learned Python." The reason why we choose Python is because it's a fairly simple language as compared to other languages. It's expressive, which means that you can do a lot of stuff with a short amount of code. And it's considered like the tool of choice for most data scientists, as well as most computer scientists as well. It's a pretty popular language. It's been well established. And we choose to use it in this class because it's not only the tool of choice, but it's also easy to learn. So it's a win-win for everyone. What we have here is a table. Each row in this table is the text of a chapter. So you can see right here, chapter 1, Playing Pilgrims, Christmas won't be Christmas, blah, blah, blah. So we have all the text here, and we have it split up by the chapters. So each row of this table contains the entire text of each chapter in Little Women. We can see here that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 chapters shown here, and 37 rows omitted because you don't want the table to be, we cut off some of the, when we display a table, we cut off some of the rows so it's not super long. So we have a total of 47 chapters in this novel, which is a good amount of chapters. So maybe we want to do some analysis. Maybe we want to look at how many times the word Christmas appears in the book. So I can tell the computer to count how many times the word Christmas appears. But don't worry about writing any of this down. This will be posted later, and you don't have to really understand how all of this works right now. But what I'm doing is I'm saying to the computer, go through all the text in Little Women and count how many times the word Christmas appears. And when I run that, it'll trumble through the text and take its time and be done. So this right here is just a mass of numbers, and it looks indecipherable. Unfortunately, a lot of times when you do data analysis, you'll get a mass of numbers, and it's your duty to kind of interpret what those massive numbers mean. In this case, we have an array, which we'll learn about later, but in this array is basically like a box of stuff. And in this box of stuff, we have some numbers. Each number corresponds to one chapter from the novel. And the number tells us how many times the word Christmas appears in that chapter. So we can see here in chapter 1, the word Christmas appears 8 times, and then it appears 9 times, and then it doesn't appear at all, and then it doesn't appear at all, until finally it comes back to 8 times, And then it's all gone, and then we have like 2 times and 6 times here. And we look at that, and we can say, well, it seems like, well, why would it appear sometimes and not others? It's possible that as the time progresses in this book, we start off the book with Christmas. Christmas will be Christmas without any presents, grumble Joe. We start off the book. The book starts during Christmas, and it goes through the year, and then Christmas again. So we have another Christmas here, and then it goes through the year and Christmas. So just from this little jumble of numbers, we can already see some patterns. We can see some patterns in what we're looking at, the data that we're looking at. So this book had 4 sisters. So let's look at how many times they appeared. What I'm going to do now is make a new table. And I can look at how many times Jo appeared in the novel. So I'm going to look at Jo. She appears 44 times in chapter 1, 21 times in chapter 2, blah, blah, blah. So what I want to do is take a look at how many times each of the sisters, Jo, Meg, Amy, and Beth, appear in Little Women. So I'm going to do that. I'm going to look at Meg, Amy, and Beth. Right. So let's do that. And what I have here, again, a pile of numbers, but we can also draw an interpretation of this pile of numbers, is we have one column for every sister in Little Women, so Jo, Meg, Amy, and Beth. Every row here corresponds to one chapter of the novel, as we had before. And what we can see here is in the first chapter, Jo is mentioned 44 times, Meg is mentioned 26 times, 23 times for Amy, Beth 26. In the next chapter, the numbers go down, and the next chapter, Jo is mentioned 62 times, so she is quite popular in chapter 3. So looking at this pile, we look at this pile of numbers, and we can look at it and find out some patterns from these numbers. But it would be nicer to kind of visualize and see if we can find any patterns like with a picture. And we can do that by drawing a line chart. So I'm going to do a cum sum, which basically means take the running total sum of each time the character is mentioned in a novel, and I'm going to plot them together. And what we're going to see is that we have this kind of plot. What this plot means is that here, so at chapter 10, Jo has been mentioned a total of 400 times so far. Chapter 20, Jo has been mentioned about 700 times so far. So we have that plot for every sister in the novel. And from this plot alone, we can already see that Jo, Meg, Amy, and Beth, we can already see which characters are important and which characters are not. In fact, Jo is mentioned significantly more times than Meg, Amy, or Beth in this novel. So we can see that although Little Women is supposedly about 4 sisters, Jo, Meg, Amy, and Beth, it's really about Jo, and Meg, Amy, and Beth are kind of side characters. And I got to do that without having to read the book myself, which is great. Saved me a lot of time. Now we can keep going and look at more characters. What I'm going to do now is give myself the ability to take that plot and add any character that I want to the plot. I'm going to do some typing. And I think I'm pretty important, so I'm going to look at how important I am in Little Women. So I'm going to run that. And clearly, I am not that important. So I think I get mentioned approximately 0 times in this novel. But you know, dreams can live on, right? So I can now take that and look at any other name that I want. Anyone want to look at how important they are in a novel? Yes, name? Kevin. Let's see how Kevin appears. Also approximately 0. In fact, I think a little bit less than me. Anyone else? Yes.
My name's Chase, so it might be kind of interesting, like if they use the verb.
Ah, Chase. Interesting. Let's see. Ah, also not important. Well, maybe if we do a lowercase c.
Yeah.
Let's try that. Oh, also not important. Sorry, Chase. Anyone else? Let's have one more. Anyone think that their name is mentioned in Little Women? No one wants to feel unimportant. One more volunteer. Let's just have one more. Yeah, in the back.
Jeff.
Jeff? Nope, also 0. So no luck here. But I do happen to know a name of one other person who is important, and his name is Laurie. Is anyone named Laurie in class? Okay, good. We would have missed you. Laurie is also a main. Laurie happens to be the boy next door, and we can see here that he doesn't get mentioned at all in like the first couple of chapters, and then in chapter 3, the girls, Joe, Meg, Amy, and Beth, meet Laurie, the boy next door. And Laurie turned out to be pretty important, so about as important as Joe, Meg, Amy, and about as important as everyone else for the first couple of chapters. And right around here-ish, we can kind of see that this is kind of the point where Joe starts getting mentioned a lot, and everyone else that doesn't get mentioned as much. If you actually go into the book and look at that chapter, we can see that around chapter 25-ish in the novel Little Women is when Joe goes to New York. And right here, so in the beginning of the novel, like Joe, Meg, Amy, and Beth talk to Laurie a lot, and Joe and Laurie talk, and you have a good time talking. And then in around chapter 27, Joe goes to New York and tries to find other people to talk to. Yeah.
It's also possible to draw from this conclusion in the graph that is that perhaps Amy and Laurie probably got into some sort of relationship. Maybe they got married. Is that possible?
So you are jumping ahead of me. Well, you spoiled my big surprise. But yeah, so it was Kevin. So Kevin mentioned that we can also look at this and draw some conclusions about the relationships of characters through this plot, which is also a thing that we can do here. In fact, so for example, here we can see that Joe starts getting mentioned a lot. Everyone else doesn't get mentioned as much. But right around like chapter 35 or so, we notice that the other sisters start getting mentioned again. And in fact, we see that the lines for Amy and Laurie kind of go up and down. But right here, every time Amy gets mentioned, Laurie also gets mentioned, and they don't get mentioned, and then they get mentioned together, and they don't get mentioned, and then they get mentioned together. And so from that, we can kind of get a clue as to the nature of the relationship of these two people. And in fact, if you go into a novel and check it out, we see that Amy and Laurie do, in fact, get together and then eventually get married. Although the relationship between Joe and Laurie looked promising in the beginning of the novel, unfortunately for Laurie, Joe goes off to New York and marries a professor, as people who are in New York tend to do. But this right here is what I call true love on a graph. It shows us the relationship between these two people. And we can do that so what have I done so far? All I've done is read in the text, count how many times words appear, and plot them. And just from those couple of steps, we can not only see who's important in the novel and who's unimportant, we can also see the nature of the relationships between people in the novel. Any questions about what I've done so far? All right. In that case, let's try to count something else. Let's try to count how many periods appear in the novel. Why would I want to do that? It's a great question. I'm so glad you asked. Well, what I'm going to do is I'm going to count how many times periods appear in a novel. And what I'm going to do is I can compare it to how many characters there are in each chapter. Okay, so in chapter 1, maybe there are 1,000 total characters, like hello has 5 characters. Maybe there are 1,000 total characters in that chapter. And I can compare the number of characters with the number of periods. So try to think to yourself as I type like what the relationship might be between the number of characters in the chapter and the number of periods. Occupy yourself while I do that. So table, new table, and I want to compare characters with the number of periods. If I do that, similar to what we've done before, we have one row for every chapter. And in every chapter, we've counted how many characters appear in each chapter and how many periods appear. And of course, this right here is a mass of numbers. So what I want to do is I want to visualize the data that I have. And in this case, I can draw a scatter plot. The periods on the x-axis And what do I notice? Talk with your neighbor about what you see in this plot here.
Yeah, it's with more characters, there are more sentences. Of course, we see possibilities.
Okay, I'd like a couple of volunteers. What did you notice just from looking at that plot? Yes, here. Name and what you noticed. Peggy?
And strong positive linear correlation.
Okay, so we're getting way ahead of ourselves. Peggy says she notices a strong positive linear correlation between characters and periods. Well, we haven't covered what those are, but basically what that means in English is they kind of follow a line, and you can kind of they follow like an upward sloping line that we can kind of see from this plot here. Great. Any other things that you noticed? Or conclusions that could be drawn? Yeah, Chase.
I guess that you could say that means is like the author uses relatively similar length sentences throughout their novel.
Yeah, so the author used relatively similar length sentences throughout the novel. Well, how did you draw that conclusion?
Well, it's sort of like there's a linear relationship between number of periods, number of characters. So it just directly goes up as you increase the number of characters, you increase the number of periods. If that line is linear, that means that as for each given chapter, the number of periods, like the chapters have more periods, generally have more characters, and the line's all linear. So that's what I'm trying to say.
Yeah, so Chase noticed that when I increase the number of characters in a chapter, I also increase the number of periods and kind of vice versa, right? So this chapter right here, right over here with 400 periods has about 40,000 characters. And this chapter right here with about 100 periods has about 10,000 characters. So as the number of periods goes up, the number of characters in a chapter also goes up. What that tells us, so the reason why I do this is because we can kind of look at this and try to figure out the way, like the length of the sentences in this novel. So for example, typically a sentence is like you start a sentence and you end it with a period, you start another sentence and you end it with a period, right? So in this particular chapter, we had 40,000 characters and 400 periods. So each sentence was about 100 characters long. This chapter right here, if you look in this region with 200 periods, most of the chapters have between like 20,000 and 25,000 characters with 200 periods, which means that every sentence has about 100 to 150 characters in it. And the same is true here. Coincidentally, that's also the length of a Twitter message. Normally, we would say, what a coincidence. Is it just a coincidence? I think not. But in this case, it actually was a coincidence. So the reason why Twitter limits its things to 150 characters is not related to the length of a sentence. However, it is very convenient when you're trying to write a sentence because most sentences conveniently fit within the character limit of Twitter. Any other questions about this? All right, well, that's all we have for today. So I'll see you guys tomorrow. Thank you. I appreciate it.